Hello friends, in this video I will explain how to solve the problems on one-dimensional bar elements. The problem statement is like this. The figure shows one-dimensional bar subjected to an axial loading. Taking it as a single bar element, determine first one, nodal displacements, stress in each element, reactions at support. Diagram of the bar element is given. In this you can observe that a small arrow mark with X is written there. This indicates right side, towards right side is a positive direction, assumed positive direction, and extreme left side of the bar element is fixed, and at the extreme right side a load of 10 kilonewton is applied. Length of the element is 1000 millimeters. Young's modulus E equal to 200 gigapascal. Cross sectional area 10 to the power of 4 millimeter square. We will solve this problem step by step. Step number 1, finite element model. Here we have to draw a Fea model diagram, that is line diagram of bar element. Here we have to represent all the parameters like displacements, force, node numbers, length of the element, like this. At extreme left side we will consider node number 1, extreme right side we consider node number 2. Q1 is the displacement at node 1, Q2 is the displacement at node 2. F1 is the force acting at node 1, F2 is the force acting at node 2. F1 is not given, so F1 value is 0. F2, that is load acting at node 2 is given, F2 equal to 10 kilonewton. Now second step is to find the stiffness matrix of bar element. The general equation is like this: K equal to A E upon L 1 minus 1 minus 1 1, where K is the stiffness matrix, A is cross sectional area, E is Young's modulus, L is the length of the element. Now these all the values are given. Substitute. A is 10 to the power of 4, E is 2 into 10 to the power of 5, L1 length of the element 1000 millimeters. Now calculate this part AE upon L, that gives the value as 2 into 10 to the power of 6. For simplification purpose, what I will do, 10 to the power of 6 I will keep it outside, only that value 2 I will multiply inside the matrix. Now stiffness matrix of bar element becomes K equal to 10 to the power of 6, 2 minus 2 minus 2, 2. Next step, that is step number 3. Step number 3, that is nodal displacement vector, Q equal to Q1, Q2. These things we are going to find now. Step number 4, load vector, that is F equal to F1, F2. F1 is 0 as I already told, F2 10 into 10 to the power of 3. Step number 5, that is equilibrium equation. Equilibrium equation is like this: K Q equal to F. We know K, that is stiffness matrix, we know displacement vector Q, we know load vector also, that is F. Substitute in this equation. Next is step number 6, that is very important, that is applying boundary conditions or imposing boundary conditions. Here we are solving this problem by elimination approach. In this approach we have to eliminate particular row and particular column. How to eliminate, which row, which column has to be eliminated, that we will come to know by looking at the given diagram. In the diagram we can see that at extreme left side, node 1, left side is completely fixed. It means displacement at node 1 will be 0. Hence displacement at node 1 is known for us. Eliminate row 1 and column 1 in the 6th step. We can see that first row and first column of the equation are eliminated here. Now write down the remaining terms of the equation. That is, remaining terms are 2 into 10 to the power of 6 into q2 equal to 10 into 10 to the power of 3. Solve this one. We are getting q2 as 0.005 millimeters. That is, q2 means displacement at node 2. q1 equal to 0 because at node 1 it is fixed, hence there is no displacement. Displacement value is 0. Next step. This is the first part, finding the displacement at each nodes. That is done now. Now second part of the problem is to find the stress in the element. To find stress in the element, we are using the equation. That equation is like this. Stress sigma equal to E upon L minus 1 Q1 Q2. Q1 Q2 are the displacements that we found already. Now substitute all the values. We know E, we know the length of the element, we know the Q1, we know Q2 also. Substitute and simplify that. Sigma 1 we are getting as 1 megapascal. Now it is the second part is over now. Third part, that is finding the reactions at the support. Equation for finding the reaction is like this. R equal to, R means reactions, R equal to K into Q minus of F. Substitute all the values. We know K, we know Q, we know F also. Substitute. While simplifying here, first I will multiply K and Q. Whatever the answer comes, that and minus of force vector. Subtract that one. We are getting the answers as R1 equal to minus 10 into 10 to the power of 3 Newton, R2 as 0. Since there is no support at R2, reaction force will be 0 there. At the end, this is third part of the problem is over. At the end, I have written all the answers, displacements, stress and reactions. This is how we solve the problems on bar elements, one-dimensional bar elements. Thank you.